In this video, we're going to look at composition of functions given a graph. So here we have a graph, and we can see that it's not linear. In fact, this here is cubic because it gives us this kind of shape. So again, I'm just previewing some things for you. So this here is a cubic function, and we'll learn more about that later. The one thing I do want to have you do is I just want you to put an arrow on both ends because this continues on both. So what we're going to do is we're going to evaluate the function from a graph. So we have to go back and we have to look at what does this mean. So if I were to simply write underneath here f at x, this means that x is -4. So I'm going to look where x is -4. So x is -4 right here. I have to find out what my output is. So I'm going to go up to my graph, and I'm looking at this point right here. And so my output is on my y-axis, which is 2. I'm going to do the same for here. So this is saying that x is 0. So what is y? So again, I'm going to go where x is 0 right here. Where is y? Well, y also has the value of 0. And then if I look here, this is saying that x is 3. So if x is 3, what's the value of y? Well, x is 3 here. What's the value of y? Well, here's the point I'm looking at. So be careful with this one. It appears like it might be -2, but it's not. If I look over here, it's just shy of -2. So I'm going to say x at 3 is where y is, let's say -1.8. And then I'm going to look at where x is -5. What is y? So x is -5 here, and y is 0. So if I were going to write these as coordinates, the coordinates would be written as at x is -4, y is 2. At x is 0, y is 0. At x is 3, y is -1.8. And at x is -5, y is 0. So that's another way of writing it. So let's look here. Now I want to know what the value of x is when f at x is 2. So you have to remember another way of writing f at x is y. So where is y equal to 2? So this one's a little tricky. I'm going to use my highlighter to show you. So most students, they think, well, y is 2 right here, but that's not the only place where y is 2. Y is 2 everywhere along this horizontal. So any place where my function touches that horizontal yellow marker line where y is 2 is an answer. So right here, I have a point here, as well as here. I have two values of x. So here, my x, bring this up, my x can be -4, and my x can also be -2. So I have two possible answers. When I input -4, I get the output of 2. When I input -2, I also get the output of 2. So the same thing is happening here. So we have to remember what this notation means. So f at x is the same thing as y. So I want to look at where y is equal to 0. So where is y equal to 0? Again, y is 0 here, but actually everywhere along my x-axis is where y is 0. And in fact, that's a very important concept. So what I want you to write here is that the x-axis is the same as where is the same as y equals 0. Okay? And this here, I'm going to do this. This here is a line. So that's the line y equals 0. That's your x-axis. So when we look here, where y is 0, I have a point here, and another one here. So I actually have 3 values that x could be to make y is 0. So that means that I have x equals to -5, or x could be 0, or x could be 4. Okay, so those are 4 possible input values to get an output of y equals 0. And in fact, where y equals 0 is very important, and we'll be learning this in a few lessons, because here are called the zeros of the function. So I'm just going to write this like this, just introducing a term. So these are called the zeros of the function. And why is that? I'm going to write this down beneath, because where x is -5, y is 0. Where x is 0, y is 0. And where x is 4, y is 0. So we can see it's called the zero of the function because it makes my answer, y, always 0.